Hello, everyone. In this video, we will introduce numeric data types and operations. Java has 6 numeric types for integers and floating point numbers with operators: addition, subtraction, multiplication, division, and remainder. Every data type has a range of values. The compiler allocates memory space for each variable or constant according to its data type. Java provides 8 primitive data types for numeric values, characters, and Boolean values. In this table, you see 6 numeric data types. The first 4 are for integers, and the last 2 are for floating point numbers. For the byte, the storage size is 8-bit. It represents value from -27 to +27 - 1. And the short double the storage size of byte. Int double the storage of short, and long is 2 times long as the int in storage size. So the long represents the largest range for the integers. For the floating point numbers, float represents a floating point number, and with a range is 9 to 6 significant digits. It's 32 bits. And double is 64 bits. It represents the numbers from this the range, and the with 15 to 17 significant digits. So the double is more precise than float. It's about double precision. You have 6 numeric types. When you write a program, choose the type that is the most appropriate for your variable. For example, if you know an integer stored in a variable is within a range of byte, declare the variable as byte. For simplicity and consistency, we will in this book use int for integers most of the time. And we'll use double for floating point numbers most of the time in this book. You can read the numbers using the scanner object, invoke its method. We already used the next double method. You can also use next byte, next short, next int, next long, next float. It really helps you if you know the naming convention. So the naming convention for method name is the first word is in lowercase, and for all the subsequent word, the first letter in the word is capitalized. So this is spelled as next byte, B, uppercase. Let's see this example. We have this input is an object of the scanner to read data from the keyboard. And this is to read a byte, input.next byte. This is to read a short value. Now, how do you read an integer? You can write input dot next int. And this is next long. And to read a float value, you can write input dot next float. These are the 5 numerical operators for performing numeric operations: addition, subtraction, multiplication, division, and remainder. For division, if both numbers are integer, the result is integer. 5 divided by 2 is not 2.5, it is 2. The fractional part is truncated. If you want to get 2.5, you're going to use 5.0 divided by 2. Remainder is the remainder of the division. Look at this example here. What is 7 remainder 3? That is 1. So y is 1, and it's a 7 divided by 3, the remainder is 1. 20 remainder 13 is 7. So 20 divided by 13, the remainder is 7. Remainder is very useful in programming. For example, an even number remainder 2 is always 0. An odd number remainder 2 is always 1. So you can use this property to determine whether a number is even or odd. Let's look at this example to display time. We're going to write a program that obtains minutes and remaining seconds from seconds. So this is the program. We prompt the user to enter seconds as integer. For example, 500 seconds. And now we obtain the minutes from 500 seconds by using this division, seconds divided by 60. And both are integers, so this is integer division. And the result is 8 minutes. And so what is the remaining minutes? Remaining minutes can be obtained by using this. Seconds, remainder, 60. And that is 20 seconds. You can use the math.pow method to compute exponents. For example, a to the b is written as math.pow ab. For example, math.pow 2, 3 is 2 to the 3, and this math.pow 4, 0.5 is 4 to the 0.5, and the result is 2.0. The term literal is a constant value that appears directly in the program. For example, 34, 1 million, and 5.0 are literals in the following statements. Integer literals. An integer literal can be assigned to an integer variable as long as it can fit into the variable. If it doesn't fit, a compile error will be rest. For example, you can assign 127 into B, but if you assign 1 to 8 to B, and this will be wrong. Because it's going to be out of range. So let's display B is, and here you are going to see, and this is incorrect. I should change this to byte. Okay. So this is byte is 128. It is too big, and 127, and this is fine, is still within the range. But if it exceeds the range, and you'll see, and that's a problem. For floating point literals, use float f 5.6. Now this is incorrect because by default, a floating point value is of the double type, and double is more precise than the float. It cannot be assigned to float. So you can use this notation, f or uppercase F, to denote that this is a float type value. So you can assign it this way. Double is more precise than the float. For example, 1.0 divided by 3.0, the result is this many digits, 16 digits. And 1.0f divided by 3.f, those are the floating point numbers, the float type values. And the result, as you see here, is 7 digits of threes. And so this is the less precise, and then the using double. Floating point literals can also be specified in scientific notation. For example, 1.23456 e plus 2, it is same as you move the point, and here is two places, move it to the right. It's 123.456. So now you see why it's called a floating point. It is, you have this as a point. You can move left or right, and as long as you change the power value. That's all for this video. Thank you for watching. See you on the next one.